G'day, and welcome to the AHDC podcast series, Health Design on the Go. I'm your host, David Cummins, and today we're speaking to Professor Ross Donaldson, who is an architect and recently returned back to Perth from Hong Kong, where he was the global CEO and chairman of Woods Bagot. Ross has travelled the world, from China to USA, UK and Australia, lecturing on the importance of climate change and how design can help reduce our carbon footprint. Currently the chairman of Bridge 42, Ridge is also on the board of the Australian Health Sustainability Council, National Task Force on the Australian Institute of Architects on Climate Change, and he's an adjunct professor at the University of WA and Curtin University, where he's a lecturer and he's extremely active in the sustainability space, which is why he's the perfect person today to interview on our sustainability series. Welcome, Ross. Thank you for your time.
Thanks very much, David. Obviously, very, very pleased to be here and to share my thoughts on what the priorities are for where we're at in this trajectory towards zero carbon construction industry. I have to say, on a personal level, I'm finding myself refocused with the sort of messages that are coming from all sorts of sources in a fresh wave at the moment, like might have seen last week. We're in November at this point of the interview. The UN report leading into the upcoming COP27 in Egypt, that whilst all the talk has been on taking action out of Paris and COP26 to get to zero carbon by 2050 to keep the Earth's temperature increased below 1.5 degrees, we're nowhere near that trajectory. In fact, we're slipping behind that trajectory. We're not making any real progress. Patches of progress. And the UN's now talking about the very high likelihood that by the end of the century, the temperature will have increased by 2.5 degrees. And there are other authorities and researchers in this area who believe it's 3 degrees. And if it's going to be into that sort of territory, a lot of very well-informed researchers and scientists talk about it reaching a tipping point. People generally understand what's meant by tipping point. For the Earth, that'll mean tipping from the self-cooling mechanism by which the Earth has kept its balance since the Anthropocene began, when people started wandering around the Earth, so that it'll move from a self-cooling mechanism that's kept the Earth habitable into a self-heating mechanism. And nobody really understands what's going to happen when that tip happens, in terms of the Earth becoming like a hothouse, just getting, this constantly reinforcing its heat. And, if the Earth's temperature continues to go much beyond that, then we're into quite horrific potential outcomes. So for any of us, we should be seriously thinking about what we're doing, what it means for our grandchildren and their children. And in the immediate focus, we have to focus on 2030. And I think many people will be familiar with the strategies that are being talked about around getting to 2030, including our own new federal government, who's talking about a 45% decarbonisation of the economy by 2030. Within the construction industry, people most generally talk about 50% reduction of carbon by 2030, 50%, not 45%. And that means whole of life carbon. That doesn't just mean operational carbon, how much energy it takes to make the building work. It means embodied carbon. That's all of the energy that goes into extracting and making the materials that buildings get built from, the industrial processes that are used to create those materials and components, the transport that takes them all to the site, and all the energy used on site. And hopefully people are very familiar with this, what's generally referred to as embodied carbon. So operational carbon, all the electricity and everything else you consume every day in the operation of the building, and embodied carbon, everything goes into creating the building before it opens and operates. So that's whole of life carbon, and that's what we have to measure, and that's what we have to get down by 50% by 2030. It's not anywhere near good enough just to talk about operational carbon, because you can imagine once you start talking about extraction and industrial processes and manufacture and transport, you can see there's a heck of a lot of carbon goes into the system before the building is opened, and so that has to be decarbonised as well by the same degree. Otherwise, we're kidding ourselves. I think there's a well-known adage that you can't manage what you don't measure. And if we're talking about us getting our heads around how we manage to decarbonise the construction industry in that time frame, then it's absolutely fundamental that we start measuring. And we start measuring whole of life carbon. There are all sorts of great initiatives in all sorts of areas of, institutions, developers, local government authorities, initiatives around greenhouse gases and trying to sort of lower the climate impact in terms of how the buildings are being built and so forth and designed. But it's a very fragmented territory. It's absolutely fragmented everywhere. There's no consistent, coherent, centralized process for measuring carbon. And the whole of life carbon I've been talking about is measured through what's called life cycle assessment, LCA. They're phrases and things that people may have heard of, hopefully. So life cycle assessment measures both embodied carbon and operational carbon. And that's what we need to be all measuring. And we need to be doing it on all buildings. And once we start measuring, we can start accumulating and analysing the data of what is the whole of life carbon for a building, which includes literally whole of life. So what's the carbon footprint that a building creates for its whole of its operational life, whole of life carbon. So we need to be doing life cycle assessment, measurement and reporting when we're designing the building. There's actually one local government authority in Australia, interestingly, in Western Australia, the City of Vincent, that 11 years ago implemented a process of requiring life cycle assessments for all development approval applications. So whatever your building was in the City of Vincent, you had to submit a life cycle assessment report with it. So that meant the designers and the client and everybody was looking at and considering what was the carbon footprint of this proposal. And then I think about maybe 5 years ago, they introduced a performance benchmark that required all of their buildings to be 50% less carbon than, I think it was set against 2005 National Construction Code standards. There was a building typology benchmark. And so they introduced the performance benchmark after they'd been measuring and looking at the data and understanding how all the buildings were performing. They did that for about 5 or 6 years, and then they introduced the 50% reduction. And they find that for most development approval applications, most of them are knocking it out of the park. 75% improvement is not uncommon. Now, that's not going to be the case for everybody, and there will be a few people in that mix who will be arguing the toss about what's reasonable and what's being imposed on them. But they've got some very interesting indicators. I think there's probably a bit of history as to why that's happening in the City of Vincent, but it came from the community. Apparently, it wasn't that it was a councillor or the senior executive in the system or the mayor. I think it came from the community. It came up the council adopted the process. We need that kind of leadership. So one of my call outs in all of the people I talk to now, and believe me, I'm doing the rounds on this stuff, is we need leadership. We need more leadership like City of Vincent. We need significant and preferably profiled institutions, maybe a hospital or a hospital developer or a hospital operator or someone like that, saying, we are going to get onto this now. We're going to take a bite of this, and we're going to start making sure that we do whole of life carbon reporting for every building. And we're going to get our consultant team to be analysing that, and in the framework of that reporting, see where the opportunities are for driving the carbon footprint of that building project down. We need local government authorities doing it. We need universities, developers, and home builders. I guess the final point I'd make about the City of Vincent is that they apply this requirement even to single dwelling. There's a terrific guy in Western Australia named Richard Haynes who developed a life cycle assessment tool called eTool, and he worked with the City of Vincent and produced I think it's called Rapid LCA or something, LCA Light, something like that, where you can do maybe a bit rough and ready, but a good approximation of a life cycle assessment for a house for $50. So, there's no argument that it's a cost impose or it's making everybody's life too complicated. In fact, I would argue it ultimately makes their life simpler because they've actually got a reporting framework that will give them indication about how they can make the improvements.
Very scary to start with, but also quite uplifting to hear towards the end. So what do we as Australians in the construction industry, whether it's in health or commercial, what do we need to do? How can design help improve our sustainability and carbon footprint?
Well, in the early stages of considering a building, before you've designed it, the first step is to think what it's going to be built from, what's its structure. And engineers will tell you that around about 70% of the building's embodied energy is in the structure. So the first thing is to look at is what are we going to build this thing out of? Are we going to build it out of concrete or steel or timber or hybrid combinations of all of those, and then take a look at what those options indicate to us in terms of the embodied carbon that's going to be in that structure, because it's going to be a significant number, 67%, sometimes more. And that's why people are experimenting with doing timber buildings, because hopefully, timber has a much, much lower embodied carbon than steel or concrete, because there's just so much less energy going into the creation of the building component. You get some timber out of the forest, you maybe glue lame it together or do something else, and then you transport it to site, which doesn't involve anything like the energy that goes into concrete and steel. So, but you can't really see or understand the effect of what your design decisions are having unless you're measuring it. That's why I keep coming back to the measurement side of it. You have to measure, and then it'll tell you and you'll be able to see the relativities of the different structural concepts that you're considering, and then you can make an informed decision. But then there's all sorts of other components that go into the building that whether what are you putting on the floor? Are you putting any kind of floor covering? Are you using paints, carpets? What kind of are you creating? Is it double glazed? What is the energy impact of the different glazing systems? One of the biggest changes that came in through Section J of the National Construction Code is the ratio of glazing to solid in the facade, and how that can change your energy requirements so dramatically. There's lots of different considerations like that. One of the other factors that we're seeing overseas, and we really should be looking carefully at what's happening overseas, where the leadership is, quite honestly, a fair bit ahead of where we are. So in the UK, for example, they're much more advanced in what's called circular economy, where you're thinking about the life cycle of materials, demolition. Do they get reused? Do they get taken to landfill? Do they simply get sort of crunched up and turned into road base, which is a lower order use? And with the circular economy focus in the UK, there are councils in London boroughs now, like Camden, for example, that will not give you a demolition permit until you've proven to them that demolition will give you a lower carbon, whole of life carbon outcome than retaining the building and incorporating it into the existing building. So no demolition, retention and reuse of existing built fabric, is obviously a much, much better way of moving towards, typically, not in every single instance, but typically much better way of moving towards a lower carbon outcome. Sometimes, the existing building may not be configured in a way that makes it easy to reuse, and you have to put so much time into, the repurposing of the existing fabric that it'll be more than if you demolished it, but that's not very often the case. So there are lots of fundamental decisions when the procurement of the development is first being considered that can have huge impacts on the outcomes.
One thing I've done my research. One thing that my research has shown is that there is always this resistance of people saying someone else's problem. We don't have the money. I don't have time. It's something we have to worry about because it's going to be 4 or 5 years away. There seems to be a lot of resistance towards this critical problem that should be shared by everyone. Like, how does one overcome such resistance barriers where people think it's not their problem?
Well, education is a factor. This part's a slightly oblique answer to your question, David, but when I talk to local government authorities, I say that one of the first things they need to do is get their building and planning officers trained up on life cycle assessments so they understand this stuff. They understand the implications of certain design decisions around materials and construction systems and demolition versus retention and all that kind of stuff, so that becomes part of their working knowledge. So that's important. And that should be the case for any client and design group. So we have got a fair bit of work to do to get the construction industry community upskilled around life cycle assessment, understanding whole of life carbon. And I think that's a very important thing. The other thing, maybe this depends a bit on the building typology, but smart boards who bring intelligent thinking and decision making around the procurement of their assets will understand, if they're approaching this from the point of view of a balance sheet, which they should be, irrespective of whether they're a private enterprise company or an institution. These things are all assets, and they all effectively sit on a balance sheet. And by 2030, and I'm absolutely convinced the momentum is going to build on this, and it'll build up around people who are drag liners on it. It'll move around them and move in front of them, move past them. And those who don't keep up with that momentum will find themselves with what is often referred to as stranded assets. That is, they'll be sitting in 2030 or earlier with a building they've completed through what I would say incomplete and imperfect, design thinking. And that building is no longer up to the standards of what is the new standard that'll be operating at that time. Now, this is particularly critical for commercial office buildings because, as we know, if you have a premium office building, there's a lot of benchmarks that apply. Green Star has played a terrific role in, driving the quality up so that if you want a premium office building, it's got to be a decent rating. That'll also apply to buildings with poor operational energy performance, and it'll also apply to buildings that have a very poor scorecard on embodied energy because these things will become legislated. And we're already seeing signs in Europe that these things get taxed in one way or another when performance is below the requisite level. So I think people who are, right today thinking about the decisions they're going to make in relation to procuring of the next project need to be thinking in terms of the whole of the life cycle of the building. What is the building's life cycle? Where does it sit in terms of its standing and reputation as an appropriate building for 2030, for that decade, that part of the century? And quite honestly, buildings that don't measure up are going to get a reputation for it. And sometimes it'll have a very direct impact on their value. Because if you've got a premium office building that's renting at premium office rates, and you get downgraded to, A or B or whatever grade, then the kind of rents you can charge and the quality of the tenants you're going to get will be diminished. But, these things will apply across the board to institutional buildings as well. And, reputation means a lot to any decent organisation, doesn't it?
Yeah, you're 100% right, because it's part of the brand, and you get more customers with that branding, and there are certain customers that wouldn't, choose not to be affiliated with a certain brand that do not take it seriously. So there's a lot of benefits to doing it. Just before we go, I could listen to you all day, but just because we're limited in time, what do you think one of the take-home messages, or what would you like to see happen, certainly in the short, medium, and long term, to how we can change this? Because 2030 is not very long away, so I'm even panicking myself. So what are some of the quick wins that we can do in the world of design, in the world of construction, to try and really implement this now into the future, especially for our grandchildren?
I'll probably go to the same point I keep banging on about, David. I think we have to start measuring, and we have to start measuring now. We need to give ourselves as long as we possibly can to be doing the measuring, to get better and better at understanding the implications of what the measuring is showing us. Because if you do a life cycle assessment of a building, it'll give you quite precisely the kilograms of carbon per square metre of that building for all of the components. So if it's full of concrete, it'll tell you how many kilograms of carbon per square metre of that building comes from the concrete. It'll give you a number for the glass, it'll give you a number for the cabinet work, it'll give you a number for the tiles, brickwork, whatever it is. It'll give you a precise number for each element of the building. And therefore, you become so much more informed, and you're capable of making a so much more intelligent decision about how much of it you use and, what are the options. For example, if you do a building with a smaller grid, it'll pretty well always give you a lower carbon footprint. You make the grid really big to give you the flexibility, then the carbon goes up because the weight of the structure goes up. It's directly related to weight, really. But until you can see these things in terms of measurement and reporting, it's so hard. All you can do is have an opinion, but that opinion needs to be informed by the science that'll come from the measurement. So life cycle assessment, start tomorrow. Get your team used to it, understanding it, working with it, so it becomes part of the working culture of both on the client procurement side and on the consultant side, and ultimately on the approval side with the authorities who are approving the building.
Thank you so much for everything you've done in your career, Ross. People like you that have certainly been, the pioneers of sustainability. I know you've been doing it for over 20 years now, and a lot of people have only started to talk about it. So without, your brains and your constant pushing, and without your understanding and knowledge and your advice, I think Australia as a whole would be behind even more where we are. So thank you very much, and thank you very much for your time today.
Very generous, David. Thanks. Pleasure. See you soon.
You have been listening to the Australian Health Design Council podcast series, Health Design on the Go. If you would like to learn more about the AHDC please connect with us on our website or LinkedIn. Thank you for listening.